that will cover a wide range of topics within the field of semiconductors. We believe this event will provide valuable insights and learning opportunities and foster collaborations and partnerships that will drive positive change and advancements in the semiconductor field. We welcome you once again to this event. We'll begin felicitation.
I would like to request Professor Rajiv Ahuja sir, Director IIT Guwahati, to join us on the stage. We now invite Dr. Charan Gurumurthy sir, Chief Executive of Tata Semiconductor Assembly and Test Private Limited, to join us on the stage. And we request our Director sir to felicitate him. May I call upon Smriti Soumya Gupta ma'am, Joint Secretary, Ministry of Education, Government of India, to join us on the stage. Next, I invite Dr. X. Lakshmanan sir, IAS Secretary to the Government of Assam, to come up on the stage. We request our Director sir to felicitate Soumya Gupta ma'am. Next, I request Director sir to felicitate Dr. S. Lakshmanan sir. Now I request Professor K.B. Krishna, Sir, Dean Academic, IIT Guwahati, to felicitate Professor Rajiv Ahuja, sir.
Thank you, sir. With no further delay, I would like to invite Professor Vimal Katiyar, sir, Dean Research and Development, IIT Guwahati, for a welcome address.
So, very good morning to one and all for joining us here today's Semiconductor Horizon workshop at IIT Guwahati. First of all, I have to welcome all my students who have come across the from IIT Guwahati and across the institutions from Assam and nearby states. So welcome to the participant. This is going to be, as you know, that Government of India has taken an initiative to establish semiconductor ventures in the different part of the country, and one we are witnessing it in Assam. And today, I really feel proud and honored that among us, we have Dr. Charan Gurumurthy, who's the Chief Executive, Tata Semiconductor Assembly and Test Private Limited. Sir has accepted the invitation in very short notice to come and to basically educate and address to our young youth and the students for here. So we would like to welcome him, sir, that in spite of your very busy schedule, you have found the time for us and you are here for us, and we are looking forward to your deliberation, sir. Thank you very much. Always, not only IIT Guwahati or the higher education, our Ministry of Education always mentoring all of us to all the stakeholders, and even I welcome Srimati Soumya Gupta Madam, Joint Secretary Technical Education, Ministry of Education, Government of India. In a very short notice, ma'am, you have accommodated us and you come here for your graceful words and deliberations. Thank you very much, and welcome you once again, ma'am. And more importantly, that this whole venture cannot be completed until the support from the government of Assam. And I would like to take this opportunity to welcome Dr. Lakshmanan, who is the Secretary of the Government of Assam, Industries, Commerce and Commerce Department, Government of Assam. Sir, you are so humble, so kind, always, for even on very short notice, you always accept our invitation. You are here with us. It really makes great impact for all of us. And along with the dignitaries on the dais, the many dignitaries are there on the dais. I would really welcome to each one of you. We are having with us Professor B.L. Ahuja ji, who is the Vice Chancellor of Bodoland University, or Professor G.D. Sharma ji, Vice Chancellor USTM, which is a very prominent university in Meghalaya. And I would also welcome other delegates from different institutions, the directors and vice chancellors. And also I would like to welcome the industry partners, because when we talk about the venture, especially in this technology-driven venture on semiconductors, the role of the startups and the industries are very important to take it forward. So I would really like to welcome to each one of you who have joined from the different startup ecosystem to IIT Guwahati and the small scale and small and medium and small scale industries who have come all the way here to join and participating in this particular workshop. Not but the least, I would also thanks to all my press media, electronic and print media. I welcome them, and I really looking forward their cooperation and to disseminate the deliberations of this workshop which will to be reached to the further to others. So with this, I really would like to welcome once again. I would like to welcome all the faculty members, staff, and the student of IIT Guwahati who have joined today's function, and some of them they will be joining. I really would like to mention that right now the examination is going on at IIT Guwahati, the end semester examination. So some of the students and faculty members are busy in those assignments. So they will be certainly going to get benefited from our online as well as offline recorded deliberations. With this, I would like to welcome once again to one and all present here. I personally feel that it will be really a great day today for all of us, as we have a distinguished dignitaries to us. And I really, sir, astonished when you said that Dr. Gurumurthy has said that he would like to interact among the students and discuss. So if you have any thoughts or queries during a deliberations, during a panel discussion, you can always come forward. With this, thank you once again.
Thank you so much, sir, for the welcome address. Now it's time to invite Professor Rajiv Ahuja, sir, Director of IIT Guwahati, to address this event.
So good morning to all of you, and especially our young colleagues who are coming from outside, from IIT Guwahati, from other part of the state of the Assam. I welcome you, all of you. And before I start, I would like to welcome our chief guest, Charan Gurumurthy ji. So he was kind enough to come physically. So when we are planning on 29th of April, and then he told me that he can join online because he was on the way, or he was coming back from Dubai. I said, no, because we want you here physically. We don't want an online interaction, and we want that. So he said that, okay, what about the 1st May? I said, we will change our date. We will move it to the 1st May, and he is here as he promised. So thanks for coming, Dr. Charan Gurumurthy ji. And of course, I would like to thank also our Ministry of Education. So I have a long discussion with Sanjay ji also. And then I tried to convince him that at least Soumya ji should come. He said that I am very busy. I said, okay, don't come, but send Soumya ji. And he not only sent to you, also Varun is also here. So it's good that we have always support of the Ministry of Education and our superiors. So they are also helping us and guiding us in this mission also. And without their support, we cannot do this all. And I will also like to thank the local Assam government, especially Dr. Lakshman. And I always say that this is your institution, so you can come anytime. And I don't treat him that he's an outsider. So we are thanks to you also for your support and your ministry support, and for this the semiconductor mission, and which year Assam is going to get one of the biggest plant in Assam, in Jagri Road. So this will be a great opportunity for all of us, not only for IIT Guwahati, but whole Assam and Northeast. And we thought that, okay, when this when this plant is coming in Assam, and I always think that IITs are the best place to be a knowledge partner to these kind of plants. So we thought, why don't we take all the university or technical institution in Assam or in Northeast and try to bring them here, and we can talk in a workshop mode. We can have a roundtable discussion. So how we can skill the people who can really employable in all semiconductor mission, not only in Assam. Of course, Assam will be the priority, but if we can supply all the skilled manpower to this plant, for Tata's plant, which may be going to be operational by mid of next year in the first phase. So we don't have much time to skilling. So we need a support from all the local universities in Assam and engineering colleges. So we can create an ecosystem in Assam. So we can attract more such kind of plant to Assam, because we can say that Assam is ready to provide the manpower for scaling for this kind of activities if it's coming to Assam. So this is really a great opportunity for us to show that what we can do as a fraternity of the IIT Guwahati. As already Vimal already mentioned that because our semester exam has started from Monday, so we cannot get many students because they're all in the semester exam mode. So, but we want to do this event as soon as possible. And we try to bring the students from other engineering colleges. I think they need more our help than people or our engineer at IIT Guwahati. So we want to give them some kind of skilling, and we have a state-of-the-art facilities, what we can have in IIT system. We have a clean room facilities, we have other equipment, we have a small fabrication facility also. So we can use those facilities for the young engineers coming from other institutions, not only in IIT Guwahati, nearby engineering colleges. So we can skill them, they can have some hands-on, they can write a proposal. We already said that when we have inaugurated this center that we always invited nearby universities and institutions to use our facility and to work with our faculty members. So when we are in Assam, this is your institutions, you should interact with us, and we are willing to help the institutions which are nearby us. And this is the responsibilities of our all IITs. It doesn't matter whether you are in Assam or in any other state. This is our social responsibility. We should help people surround us, and how we can upliftment of their life. That is key important. And in this case, when we talk about the semiconductor industry, we want to give a skilled manpower to this activity of the Tata plant. When we talk about semiconductor, of course, India wants to be a manufacturing hub also. And living for last 32 years in Sweden, I know how important is industry-academia interaction, industry-academic collaboration, and how important is the semiconductor. And I will say that, I always say that in future, the country which will lead the world, it will be who lead the semiconductor industry. So we want to be a leader in this area also, and we have started now. Of course, we are not starting directly the chip manufacturing, but we are starting with the packaging, and this is a way to start. We cannot jump in directly in a manufacturing, but we can start with the packaging and assembly, and this is the first step. And if you look at all the other countries like Taiwan or Korea, they also started with the packaging, and now they are one of the world leaders when it's called the chip manufacturing. So this plant will serve not only for IT industry, it will be for even for automotive industry around in India, and it will be provided support not only in India but outside the world also. We will have a customer. Tata, of course, have their strategy how they will lead this institution, not only for this plant, not only for India, but how we can expand in other countries also. And the scaling, what we are going to do, and we have a clear discussion with many governments outside India that when we're talking about the semiconductor industry, we will run a joint degree programs or double degree program with any other countries like Taiwan or US or Korea or Japan. So we can retain those skilled manpower in India, because when they do a joint degree program, so they spend some time here, some time in other countries, and most of them going to work in a semiconductor industry. And big semiconductor giant are coming in India, for example, Micron is also coming. So why we send our students to those countries when they are coming here, so they can really directly employ to those companies, and we can retain them in India. So this is our idea when we are talking about joint degree or double degree program in other universities. So we need this skilled manpower in India. And the semiconductor industry need a very skilled manpower. It's not like a normal industry. So we have to really be the state of art in not only in the facilities, also state of art in the skilling also. And India has the right potential. I can tell you, India is one of the youngest country in the world. We have the youngest population, and our average age is around 30 years. And I was telling in the morning, Dr. Charan, that at least in IITs, in IIT Ropar, our average age of faculty is 37 years old. So that's a plus point for us, actually. And these young faculties, I'm sure, I know that in Guwahati also, half of our faculty is young, half of them are professors. So I already say that these young people will drive the institution, and young people will drive the younger IITs, and they will drive the country. So they have next 30 years to work for the institute, work for the country, and they are full of energy. So this kind of changes we are making also, and try to put in the front the young people of our country, young people from our IITs. They should be in the front and lead the institution from the front. And of course, when we're talking about semiconductors, we are talking about our own research system. So we want to put more PhD students in this area, and we will try to give them opportunity so they can stay in India. And for example, IIT Guwahati has more than 2,500 PhD students. So if we can train them, maybe out of 100 or 50 in the area of the semiconductors, that will be help not only for IITs, but other surrounding companies who are leading in the semiconductors. So we should have the everything here in India. So when we talk about these kind of plants, we are also talking about the full supply chain. And of course, the full supply chain will come also to Assam. And that will also give the job opportunity in other areas also, not only in the semiconductor. So opportunities are going to be created, and they will be, Assam will be the hub of the semiconductors, and we should be proud of that. Out of these two plants which Tata has decided, one is in Assam and other in Gujarat. So we are very lucky that and they are in Assam. And we are also being proud to be associated with Tata's. And we want to be, IIT Guwahati should be a knowledge partner. So for such activities, when it's coming, Tata is coming here. And we will like to work with all institutions in this area and other IITs in these countries. And of course, especially the older IITs. So how we can provide a common platform for skilling for such high-end industry. And I'm sure in the future, we will not rely for our chips or sensors or small thing to other countries. We can make this in India. And that is also the thinking of the government also, that we should not rely on other countries. We should be a self-dependent country, and this is the right time. Because in the way India is growing, it's the right opportunity for all of us. I can tell you, when we studied, we don't have that kind of facilities and opportunity in India. Right now, we have a right opportunity, and this is the right time for our young people to lead the institution and to lead the companies and to lead India in the world, and so that we can make this India is a world leader in semiconductor technology also. As I already told in the beginning, so whoever leads the semiconductor industry will be the leader of the world. So India has put one step in this direction, and we are all together in this venture, together with Tata and any other semiconductor industry which we are willing to come to India. We will try to work with them. We will try to work with as close as possible with Tata Semiconductor Assembly and Test Private Limited, which are setting up here. And I will say that this will be a win-win situation for all of us. So we will not get exposure to the state-of-art facilities in IIT Guwahati, as well as this in the plant in Jagi Road in Assam. And I will say that the ministry is also setting up this research park. So research park is also going to play a key and important role when we are talking about semiconductors. We are talking not only the semiconductor industry, we are talking about the medical equipment industry also. They also require a lot of these semiconductors and chips, and mobile phone, of course, and automobile also. So there are vast area where we need this thing, and we want for a faster and computer also, we have to design new kinds of chip also. So we have a lot of opportunities which are going to come with this venture. So I will not take much time, and we want to listen Dr. Charan Guru Murthy, what is their plan, and he is one of the experts in this area. And I know that all our young people, especially from the neighboring colleges who came here first time, they are going to meet. They are going to meet, as well as they are going to listen to Dr. Charan Guru Murthy. So this will give a drive to our young students, where India is going, what India wants to do, what India wants from our young kids and young students and our young faculties, and where India should be in next 20 to 20 years. With that, I will stop here, and I will like to thank you, all of you again, and especially people from ministry, from central government or state governments, or all the vice chancellors and directors from other universities in Assam and Northeast. You are all welcome here, and you have a full day to explore the IIT Guwahati. Please go around also IIT Guwahati and see if you get the time to look at our facility. We have one of the best facilities in India, and especially in the Northeast. So thank you, all of you, coming here. And with that, I'll stop here. Jai Hind, Jai Bharat.
Thank you, sir. Let us invite Dr. Lakshmanan S. Sir, IAS, Secretary to the Government of Assam, Industries and Commerce, Mines and Minerals Department to address the gathering.
A very good morning to one and all present here. Respected Director and the host of the day's program, Rajiv Ahuja sir. Soumya Gupta ma'am, Joint Secretary, Ministry of Education, Government of India. Dr. Charan Gurumurthy sir, who is the main attraction of the day. Chief Executive Officer of TSAT, who has been guiding us, in fact guiding Government of Assam in the last 1.5+ years for all our endeavor for establishing a semiconductor plant and the industrial setup in Assam. Respected Vice Chancellors of Bodoland University, USTM, the most respected teachers and faculties of IIT Guwahati, my dear colleague Sri Manavendra Pratap Singh, Managing Director, Assam Industrial Development Corporation and Secretary, Actist Department of Government of Assam. Industries partners who have come from far and near of Guwahati. Dear students of IIT Guwahati and other educational institutions who have been the strength and the primary targets of today's program. And most importantly, the startup ecosystem, represented by the most liberal, the most thought-provoking young representatives from different parts of Assam. Sri Kamaljyoti Bhuyan, Deputy Secretary, who comes from the MSME background. All guests of today's program. This is indeed a very, very proud moment for us. And I must thank, in fact, I am representing Government of Assam, Honorable Chief Minister of Assam, Dr. Himanta Biswa Sharma sir, Chief Secretary, Dr. Ravi Kota sir. Both of them would have been more than happy to be present here today. It is my fortune that I am standing in front of you, but had Chief Secretary sir been here, he would have definitely attended today's program. And I must say, Satyam would be, Satyam Sharma, who is one of the main organizers of the program, would know that when he went to invite CS sir, unfortunately CS sir had a committed program in Chennai today. Otherwise, sir would have been definitely standing here and delivering this speech, not me. That much from state government, we are looking forward for semiconductor. I cannot say it is only a planned or a investment, it is a movement rather. And the state government is totally committed to this cause, and we want the whole of Assam to be aware, to be part, to be the integral part of the success which is anticipated, which is going to be the outcome of this semiconductor movement in the state of Assam. And at the same time, I must say, Government of India, with its absolutely brilliant vision for the future, let us say Vikasit Bharat 2047 has absolutely brought in the concept of integrated development of all sectors related to IT, electronics, semiconductors, and ISM, Indian Semiconductor Mission. The primary purpose of the ISM itself is for the same. At the same time, it is not that it is just driven by Ministry of Electronics and IT, but various ministerial components, whether it is education, whether it is related to trade and commerce, whether it is related to DPIIT, all the departments help, all the ministries help in developing a very, very sustainable semiconductor-based industry model in India. And as we see, just for a moment, when we hear about semiconductors, most of us sitting in this hall would have heard about semiconductors when we prepared for the entrance, right? Somewhere in class 9 or 10, there would have been a chapter on semiconductors, silicon, germanium, something like that. And that is what we carry most of the time towards whenever we work, unless we are becoming the part of the industry. But now we have a big challenge. What about the large majority, let us say 99.99% of the general population may not be directly linked or aware about what happens in semiconductor industry, what is it. Of course, they might be utilizing a mobile phone or a car or a remote control, but whether this industry has a direct impact on their life, economy, and income. That is where bringing the awareness to the general population, mostly the students, is going to be a big challenge. That is where Government of Assam is working closely under the directions and guidance of Government of India. At the same time, Just awareness is not enough. What is the next step? On the basis of that awareness, how much activity we are able to take up. And there will be absolutely certain institutions which will be leading, certain people who will be the pioneers to take up the awareness to the next step, that is actual activity. And I'm sure IIT Guwahati is going to be that pioneer for our state, not just because you have that technology, but the attitude, that ability to work on that line with lot of knowledge, conviction, and at the best, with the ability to deliver it to the larger public. And I'm really thankful to Rajiv Ahuja sir, the whole team, Parmeshwaran sir, and all team who have been able to organize such a beautiful program. And let us see this as one of the first steps of taking semiconductor industry to the developers, to the startups, to the general public, mostly through students and to various educational institutions, so that in the coming 4, 5, 10 years, we have a ready youth who are capable to cater the needs of the industry as well. I'm sure today we all are eagerly awaiting to hear Soumya ma'am and of course Sharan sir, who would be speaking about the industry, how or what exactly happens in semiconductor industry, what kind of research and development is done or will be required, what would be the role to be played by educational institutions, especially technical educational institutions like IIT, and what kind of job opportunities, startup requirements would be coming up. So at the same time, a very small, I will not say small, but a very significant kind of support comes from the state government. If somebody asks whether state government produce some semiconductors, we will never be able to. But can we support somebody who is making a semiconductor? Of course. So that starts from the land, from the electricity, from the basic amenities, from the support system, from the incentives, from every step which makes it smoother to deliver, or let us say the most efficient way to deliver. So that is where we look forward from the state government. It is our commitment that under the guidance of Honorable Chief Minister sir, Chief Secretary sir, all the government ecosystem is absolutely supportive as well as aware about the needs and requirements of this sector. Now, lastly, I would like to come to one point, that is regarding startups. Whenever we say that a semiconductor industry or a new artificial intelligence or say new IT avenue is opening up, suddenly we think that, okay, there is lot of scopes for startups. But to make advantage of that, we have to be very much aware about certain critical gaps. What exactly is not there? Because it is not that many of the services are not available all around. We have to bring in something new. It is not very easy to find out what exactly is new. And when we say research and development or startup in that sector, let us also understand that there are certain core areas within semiconductor setup, but at the same time, equally important, perhaps more remunerative, auxiliary systems are also there. So the way Intel or somebody had taken up semiconductor business to an unbelievable level in terms of money, in terms of reach, in terms of impact in the overall industry, not only within semiconductor, they have actually entered into all kinds of industry. If you see a car, it might look like automobile industry, but it is running under the control of some semiconductor based equipment, even a part. So that way, semiconductor industry has entered into, or their products have entered into all sectors of industry. Same way, there are certain services, let us say fintech is there, or say HR management is there, or say simple amenities, hospitality or entertainment, residential facilities, simple cleaning services. So all these also require some startup mentality, a new approach, and I am sure all those activities will also be addressed, thought about, and taken advantage by our growing startup community. And without further making my speech longer, I would just like to say one point. We are on the verge of a technical revolution as far as the state of Assam is concerned. for a longer period, people who come from outside Assam would have heard about Brahmaputra, would have heard about Rhino, would have heard about petroleum or say tea. But there ends what we have heard about Assam. But today, when people speak about semiconductor industry, in the same breath, in the same sentence, like we have a big semiconductor unit in Tamil Nadu or Karnataka or Gujarat, let us be proud that the same sentence also have Assam. And that is why it is our opportunity, our commitment that not only it is an industrial event, but an event in our combined awareness, a community willingness to support the industry, to grow with that and become better with that. I take this opportunity once again to thank Rajiv Ahuja sir, the whole team of IIT Guwahati, Soumya Gupta ma'am, and especially Charan Gurumurthy sir to be present amongst us and to guide us for our future endeavor. Thank you all. Have a wonderful day.
Thank you so much, sir, for joining us and for the insightful thoughts. Now we would request Srimati Soumya Gupta ma'am, Joint Secretary, Ministry of Education, Government of India, to deliver keynote address.
Respected dignitaries on the dais, vice chancellors, faculty, students, thank you so much to Professor Ahuja for inviting me here. It's quite an honor to be here amongst you today. It's always the pleasure to be in an educational institution. The energy and the conversation is quite electrifying. I know that all of us, including myself, we are all hankering to hear Dr. Gurumurthy, so I'm not going to make this too long. For us in the ministry, IIT Guwahati has always been the shining jewel of the Northeast. Whenever we see a good project or look for some solution, we turn towards IIT Guwahati, this side of the country. And we believe that IIT Guwahati in there is uniquely located, uniquely poised, and uniquely placed to be, the technological wind beneath the wings for the entire Northeast region and its technical development. We are hoping that more and more of the research which happens in this institute will become translational research, thus helping the industry move forward in the area. I thank Professor Ahuja for all his, he has been taking IIT Ropar forward with leaps and bounds, and he has brought the same energy and vision to IIT Guwahati. I congratulate you all. You're about to get your new director, and I request Professor Ahuja to guide the new director also. And once again, I look forward to a very engaging and interesting session. Thank you.
Thank you, ma'am. Now I invite Shri Narayan Conver sir, IAS, onto the stage. I request Shri Narayan Conver sir to say a few words regarding the event.
Thank you so much, sir. Now it's time to introduce our distinguished speaker for today's event, Dr. Charan Gurumurthy sir, Chief Executive, Tata Semiconductor Assembly and Test Private Limited. He is a distinguished leader with over 20 years of experience in the semiconductor industry. His expertise spans various domains, including technology development, multi-billion-dollar high-volume manufacturing, global supply chain, factory startup and transfer, die package board interaction, substrate offset technology development, system integration, optical assembly, and complex program management. Throughout his career, he has driven innovation and contributed significantly to semiconductor technology. He holds remarkable track record with 55 plus patents issued and submitted, and has authored 15 plus publications showcasing his commitment to advancing the semiconductor industry. His dedication, expertise, and leadership have earned him great recognition in the semiconductor industry. We are honored to have him as a distinguished guest for today. Please join us in welcoming Dr. Charan Gurumurthy sir with a big round of applause as he shares his keynote address.
Good morning. Come on, guys. Every personality that spoke before me talked about the energy in the Northeast and everything. Good morning. Good morning. Okay, now it feels like it. So great pleasure to be here. First, I want to thank Director Rajiv ji, Soumya ji, good friend Lakshmanan ji, IAS officers that are here. So great pleasure to be here. Sincere thanks for inviting me here. So how many of you here are students, either IIT, Guwahati or other institutes? Can you raise your hands? Fantastic. That's like more than 90% of the crowd. That's why I'm here, right? To interact with you, to not just speak to you, but to hear from you. How are you thinking? What are your feelings? How do you feel you're going to contribute to semiconductor industry and for the building the nation together in the high technology industry for Assam and for the world. So that's the main reason. So let's make it very interactive. If I do not hear from you, so I'm requested few mics to be around. So any of you would like to share thoughts even while I'm speaking, and also direct what would you like to hear from me. That will be super helpful, please. Let's make it very helpful. Is it okay? Okay, fantastic. So how many of you heard about semiconductors? Can you raise your hands? Wow, that's half the game won, right? So what is unique about semiconductors? It is neither on the conductor side nor on the insulator side, so it's uniquely placed in between. So we have the ability to toggle it to make it a conductor or toggle it to make it an insulator. So that implies that there is a state that's 0 and 1, and that combination of which can do wonders to the world. And it's ubiquitous everywhere, right? Your cell phone, your laptop, your electricity grid, your smart, your car. I look at car as an electronics on wheels. That's the future of the car, right? Driven by electric vehicle controllers, everything driven by semiconductor. Hence, that's the significance behind semiconductor. It's everywhere. The next question that will naturally come is, why can't we just import it from somewhere, from China or somewhere else, and why do we need to do semiconductor by ourselves? And I really want somebody to answer that question rather than me. If there is a mic, if somebody can raise their hand, and somebody who is already a volunteer, is there a mic? Okay. So can you say, why do we need to do semiconductor by ourselves?
So the biggest issue is global supply chains, which I personally feel. So supply chain is something we need to control in order to meet our needs. So I think, yeah, that's the answer.
That's a very good answer. We talked about global supply chain. Thank you. That's one of the primary reasons. Anybody else?
And the national security, sir. Because you would be compromising on such kind of effort when you are importing such kind of important chips going to your...
Mic closer, please.
These chips when we are importing from other countries, not naming anyone, but you are compromising on your national security because it's have an impact on cyber securities, which we are basically reading in daily days. So
Okay,
that is
so dependence on a foreign nation for such a critical piece of technology. In addition to that, there is a certain national security aspect too, because this goes into defense electronics, this goes into all your electrical grids and everything. So there is also a certain national security perspective. Good point, thank you. Anybody else? We have a hand here.
Yeah, it's going to be the next big fuel for the economy. So, and it will help us be a more export-oriented nation in terms of electronics component.
That's also a very good point. Thank you very much. So it is a huge driver for the economy. So most advanced nation, if you can see, has been investing heavily in this area. And as a large country, and we should also be investing in the area. And not just how much investment you have directly into a semiconductor manufacturing plant. The amount of ancillary industries that needs to support a main semiconductor plant is 10x to 20x the amount of investment that actually goes into a semiconductor facility. So that drives the economy. I give you one example, right? If you look at Penang in Malaysia, right? 30 years ago, Penang was 50% economy was contribution from agriculture. And today it is about 7 or 8. And Penang's per capita income is about 2.5 times larger than the average per capita income of Malaysia. And what drove that, right? Is because the first company that actually came and set foot in Penang is Intel. And if you guys read my introduction, I worked for Intel for 22 years. And that changed Penang. And today, Penang accounts for like 10-12% of world semiconductor business, and the economy of Penang is primarily driven by semiconductor and associated. And the amount of the GDP growth is far more substantial than that of the average GDP growth of Malaysia. So I look at like Assam as a parallel. Assam is also roughly like 47-48% agrarian today, right? So the vision that I see for Assam, not after 20-30 years that it took Penang, but maybe within 5-6 years of how we work together collectively, that Assam has the potential to change the economy dramatically for Assam, for the country, for the world. Thank you. Anybody else has a comment?
Good morning, sir. Good morning, all of you. Myself, Dr. Tashir Ali Sheikh. I am a lecturer of Residential Girls Polytechnic, Golaghat. So, apart from the national security for the increases of the economics of the country and other things, one thing is that for the increase of the employment, that means job creations, it will be hugely, as some report of the government of Assam, they have said that almost 30,000 jobs will be created after the installment of this semiconductor industry at Jagirot Morigaon. So we sure that our northeast regions, so our students also, as well as the young researchers, all the educational institute will be helping this project, and definitely our institutions will be prepare the young minds for contributing greatly in this project. So I'm also very much excited to become part of this this unit. So I think our Northeast students and young researchers will be get good opportunities, because very young talented guys are moving here or there for their job. Someone is moving to Dubai for other companies like Taiwan. They are moving for their job. So if these types of facilities like semiconductors facilities, if it is set in Assam, so definitely this talent will be utilized over here, and they will be do something for their countries also. So within this line, thank you, sir.
Thank you very much. I mean, this is a very good comment. Talent is the foundational for any industry, more true for the semiconductor company. And I'm sure that many of you might know, semiconductor is the most complex set of processes conducted by human beings around the world, right? We are dealing with transistors that are in the dimensions of nanometers. A nanometer is like maybe 1 or maximum 2 atoms, right? So just to give you an example, there was one time President Obama visited Intel, and we were showing him a tunneling electron microscope, and there were a couple dots here and there. He looked at it, what are those dots, right? And then we said, those are the atoms. And then he said, really? Right? I mean, it was like a president behaving like a child, because you were showing him how does an atom look like. So that's the dimensions that you will be playing. If you look at the dimension of your hair, diameter of your hair, not the length of your hair, diameter of your hair is about like 10, 15 microns. So 10,000 times smaller than the diameter of your hair is the dimensions that you will be playing in the semiconductor industry. So this is the most high-tech thing, cool thing that I see the students here, right, that you can work on. And so I look forward to you to be very energetic, because it needs a lot of talent. And a lot of talent, not just people to job, right? It requires core foundational expertise on lithography, on tracks, on wet processes, dry processes. This is so sophisticated. The equipment runs into millions and millions of dollars. And so we need the most intensely trained workforce that we can generate to be able to run our facilities and to be able to compete successfully around the world, right? This is about, like, it's not just about technology. You need to be able to bring in quality, cost structure at scale, right? Scale is very important. So develop the technology that is affordable, that has the highest level of quality, that has the highest levels of scales. And also semiconductor industry cares a lot about sustainability and social governance. And that is why it is very apt that Tata is getting into this business, because Tata fundamentally as a company has pioneered sustainability and social governance. Many of the labor laws in the country has been pioneered by Tata. So sustainability, how much we reduce, minimize, reuse, or even make it a net positive water usage. Similarly on green energy usage, etc. Our goals that we would set on the semiconductor industry from a sustainability standpoint will be very high. So right from the first few minutes of discussion, you guys would have seen this is not just a electrical engineering thing, or electrical plus mechanical, or electrical plus some physics, or applied engineering, or chemical, or civil engineering, or anything. It's a combination of every single engineering and science and finance and other disciplines to support this industry. So that is what is the beauty of this, that it requires a village to make this industry successful. And we look forward, and we have received fantastic support from government agencies and from academic institutions and every form possible for us to be able to come here. We are just beginning. We have a very long journey to go, and we look forward to successfully to do it together. So next I was thinking about talking about semiconductor, what is semiconductor process, and then talk about what type of jobs are there in semiconductors and everything. But I want to hear from you, one or two people. Can you say, what would you like to hear? Can we pass, anybody, raise your hand? What do you like to hear? Okay, there is a, can we bring the mic here, please?
We are not getting many semiconductor industries in India, so why it is not basically?
Okay, why India has not been having semiconductor industry too far, and it's not because we have not tried, right? There has been many tries in the past. Semiconductor industry, there are few characteristics. It's a very capital intensive industry, and it requires significant amount of infrastructure, right? Infrastructure not in terms of just the factory infrastructure, but ecosystem, right? For example, all the gases and chemicals, and even to bring in a lithography tool, you need a truck that will have an airbed truck so that the tool is not getting bounced around. So you need airport infrastructure, ground infrastructure, transportation infrastructure, so multiple infrastructure. So you need heavy capital investment, you need heavy infrastructural investment, and plus multiple other things, right? Rather than worrying about like why we were not successful before, we should take pride in the fact that here we are sitting on the threshold of building this industry for the nation, and we will talk about what we need to do for us to be successful now. So that is how I would like to approach. And one of the unique things you may know that a semiconductor fab is not just the foundry or the fabrication facility that you see above, and typically it is suspended above the air, so that you have to separate the building from the floor and floor from the building. So it's suspended in the air so that even there is an earthquake region happens, the fabrication site is not impacted. Right? So it's a very complex building. Another example to give is you have to operate, when you're dealing with a nanometer, you can't let people into and go play, right? Because no offense meant, right? People have a lot of foreign particles in us. If one hair falls, that will kill your whole wafer, right? $20,000-$30,000 worth of wafer. So you have to be able to create clean rooms. You have to go in a full bunny suit when you go inside a clean room, right? So there are many things that are needed. There are talent that is needed, infrastructure and connectivity that are needed, and also huge capital investment that are needed. And what would also be helpful is having product companies co-located with us or participating very closely with us. So those are all North stars are aligning now. So let's think about what we need to do right now so that we can be very successful. I mean, the things that I mentioned, the things that I mentioned were all in various stages of development and maturity. And even now, it is not that we have everything, right? So we need to build all this together. I mean, I give you an example. We were talking to one of our customers, and they were saying that we would do our fab in Singapore, and then we will ship it overnight around 9 p.m. So it will reach India by 2-3 a.m. They said, like, process it and build all the ICs, and then put it on a plane by 5:30, 6 p.m. so that we can get it by our 6 a.m. And then so we can warehouse, do the final checks, and ship it to the customer. That's the pace at which this industry works, right? So now we understand how fast the factory has to operate, how much the infrastructure has to collaborate, and many of them are very sensitive, right? I mean, if you see a semiconductor wafer, how do you store it? Static. If you touch a wafer by hand, you're done. That wafer is done, right? Because naturally we have a lot of static electricity in our body, and most of the silicon operates in very low voltage. So you have care for, like, static electricity. The clean room implies that the circulation of the clean room, the filtrations of the clean room, and there are many aspects of the infrastructural elements, and that we believe that we can build, and that's why we have made this investment, and moving forward, I strongly believe we'll be successful. Okay, so something unique. Sorry, go ahead. Do you have a comment? So the question is, what is the process flow and what are the allied industries that are needed? I certainly will cover that. So the first question is, like, how many of you have seen or even gotten close to a semiconductor wafer? Can you raise your arm? Okay, that's quite impressive. At least I see like 15, 20. Can someone answer why is a silicon wafer almost round? Why not square, rectangle, whatever? Why is it round? Somebody? Because, sorry, can someone give a mic here, or you can raise your voice? Why? You're right? I mean, the wafer is a circle, plus it comes from an ingot, and the ingot is a cylinder. Why cylinder? Why not a square? Easier to polish? That's not the... Sorry? Structure of silica. No, the main reason is this, right? All the fanciness that we talk about semiconductor, the foundational element of a semiconductor is sand, right? So you melt sand and you build the silicon crystal from a sand. So when you melt the sand and you purify it, ultra purify it, and then finally you get a liquid of silicon. And then you come with a single crystal, your point tip, typically a diamond or something, your crystal initiator, and then that creates the seed from which you build this ingot. And from the ingot later you dice the ingot to build individual silicon wafer. And when you build it, and it takes a very long time, you bring a diamond tip into a molten silica, and then you gradually rotate it and move it up. And that is why, and when you move it up, naturally it's a circle. It's not, square is not the natural thing when you rotate something. So that is why it's a cylinder, and you dice this cylinder to form this individual wafer, right? So that's why you see it in a circular pattern, not any other random object that you can think about. So now that you have a silicon wafer, which is like a single crystal of silicon, right? And yes, single crystal, many of you would have done courses in material science. Yeah, single crystal is very, very strong. It's only defects that make a material fail quickly. So if you do not have a defect, it's very strong. You know, I've been surprised that take a silicon wafer and you grind it 50 microns, roughly the diameter of your hair or so. You can take a large 300 millimeter wafer that looks this big and round. You can bend the edges and make it touch each other and take it back. It will not break, right? So that's how pure a crystal that you are starting with, and that's what you use as your substrate on which you are going to build your semiconductor. So that is one unique thing. So that tells you about the complexity of this process. Now that you got yourself web, that only gives you a foundation to build upon. So now you have to build your first layer, which is like your transistors. And the transistors are in the nanometers. And your wafer is today up to 300 millimeters. So you can fit maybe 100 billion transistors into this wafer, right? So every single wafer has this many number of transistors. So building the transistors and depositing and doping and building these transistors is a challenge. But after you have successfully built it, what can you do with 1 nanometer thing? You cannot connect a wire to something that is 1 nanometer in dimension. So you have to bring it up to a dimension that we can deal with physically. When you see an electronic components, you see it like reasonable size thing, right? These are big enough that you can hold it in your hand and so on. But you can hold a nanometer in your hand, you won't even know where it is. So basically, to be able to connect all these billions of transistors is a very big challenge, right? If I just have transistor here, it's not good enough. You have to be able to connect them. It takes multiple layers of metallization to be able to connect all these transistors. That is when it becomes an integrated device, right? So I'm not going to go into details of every single process steps, but foundationally, you take a semiconductor wafer, you build the transistor layer, and then you connect all these transistors through miles and miles of wiring. If you take a chip that drives your car, like your anti-lock brake systems, and the chip is probably like 1.5 by 1.5 millimeter. Can someone guess how many miles of wiring how many miles of wiring it takes to connect all the transistors that will be there in that 1.5 by 1.5 millimeter device? Can someone make a guess? Is it like few millimeters, few centimeters, few meters? Anybody? It's a quiet crowd. Okay, guys, if someone is thinking but hesitate to say, if you say it could be 1 mile, 2 mile worth of wiring to connect them, that happens within that device, you are about right? So that is how much of interconnections that needs to happen. And this wiring interconnection is again in the nanoscale. So we need to start at the nanoscale to be able to connect the transistors, then build it up, build it up, build it up. And when you get a real wafer in your hand, the top dimension of your wafer is in microns, right? 10 microns, 15 microns. So at least you have got down from a nanometer playing with 1 or 2 atoms to a micron level. So micron level, you are talking, okay, your hair diameter is 50 microns, so you are 10 times smaller than that, which is like imaginable. So that again, you cannot take a wire and connect it to microns. So that is where semiconductor assembly test plays a critical role. And that is what we will be doing in Assam, to be able to take this micron and interconnect them so that it can talk to the rest of the world and can become a real electronic product or a semiconductor IC, right? So that's the complexity that we will be playing with here. So far, am I good? People following me? Okay, so that's, so what does it take when I say that you need to do semiconductor assembly and test, right? Is it just like, so is it just like, am I going to take something and put an assembly by hand and then glue something and connect a wire to it, right? If it were that easy, this many of us will not be sitting here and dreaming about what we need to do, right? So this needs to be in a fashion that to connect that 10 micron in dimensions. And also it's not just a dimension of the interconnection, number of interconnection. So just to give you, many of you use laptops here, right? So two questions related to laptop. The semiconductor CPU, typically it is Intel, AMD, the semiconductor CPU, how many interconnects do you think between the semiconductor and the semiconductor assembly substrates? How many interconnects, how many connections do you think are there between the silicon and the substrate? Anybody wants to make a guess? And typically it is like a 8 millimeter by 8 millimeter by 8 millimeter or 10 by 10 millimeter silicon device. How many interconnects in that 10 millimeter do you make? Anybody want to guess? Die to the substrate. Die on the packaging. Packaging, okay, package. 1500. Okay, so 1500 is one guess. Anybody else? Okay, guys. It is like, you want to make guess? Okay. So it is like 1500 was the guess, and little bit low. And in a high-end computer device that you are handling, there will be about 10,000 interconnects in between the chip and the substrate or the package. And that 10,000 need not necessarily be per 8 millimeter by 8 millimeter. In the most advanced, suppose it is a complex server or something, very, very high-end compute device, it is 10,000 per square millimeter, right? 1 millimeter by 1 millimeter will have 10,000 connections. So now you can see it is not just the dimension of the connection, it's also the number of the connections. And if one signal fails, then there is no redundancy, right? There is no redundancy. If one signal fails, the device has failed. That is how complex that your computer is, and you can see how stable it is. 5 years or 7 years of its reliability, it goes through humming very well. So think about how much engineering it takes and to be able to do that interconnection. That's the type of thing we'll be doing in Assam. That tells you what is the kind of engineering talent, technician talent, integration talent, validation talent, testing talent that we are looking for in this state to work with us. You guys are ready? Okay, I scared everybody. Okay, so don't worry. I mean, we are all in this together. We all have to share knowledge, learn from each other. There will be a significant amount of training to be able to become a very productive engineers. And also the next thing I want to talk about, right, this probably is an appropriate point. How many of you have a phone that is more than 10 years old? 0. How many of you have a phone that is more than 5 years old? 2. I don't know from which part of the world you are, right? So basically this shows, right, it's not that you buy it once and you're good for 10 years. The semiconductor industry, you have to be on the treadmill of innovation. Maximum, if you, in 1.5 years, if your product, one SKU can lose, life cycle of a product can lose, you're doing great, right? Many of the electronic, like toys and everything, is 6-month cycle. Phone is maybe a 2-year cycle, 1 to 2 year cycle. Computer is 2 to 3 year cycle. That is how fast these things change. But the level of technology that changes, advances that happen in all these electronics devices is exponential, way more than exponential. You can go and suppose, I talk to you, suppose there is a billion transistor, right? And that's, let's say, 90 nanometer silicon mode. The moment you go to a 45 nanometer silicon mode, in 2 years, number of transistors goes up by 4x. So from 1 billion to 4 billion. Then again it goes another 4x in another 2 years. So in 4 years, you have gone from 1 billion to 16 billion, right? That's at which this industry moves. That's the pace at which innovation can move. And how many of you have heard about Moore's law? Great to hear. Can someone get a mic and say, describe what is a Moore's law? Oh, there are many hands raised. Please, someone raise your hand, please. Okay, here there's.
Number of transistors doubles in every 18 months in a semiconductor.
The number of transistors doubles every 18 months. The cost of the transistor comes down every 18 months, right? So that implies that I could have a device that big and it goes 1/4 the size every 18 months. So that implies I put more and more into it. What used to start as just a compute module, then we put the video processor into it, then we put graphics into it, then we put memory into it, then we put I/O controller hub into it, then we put North Bridge into it, South Bridge into it. So the size of the chip does not change, but the functionality just goes exponentially up, unbelievably up, right? So that is the significance. When I started at Intel, right, in 2002, and we were in 90 nanometers. And then there were many people in the media that were writing, Moore's law is dead. Intel cannot push Moore's law anymore, right? But I'm happy to say, we are talking like 23 years down the road, Moore's law is still going. But if you think about it, from 90 nanometers to 45 nanometers to 32 nanometers to 22 nanometers to 10 nanometers, 8 nanometers, 5 nanometers. Now we have stopped forgetting about nanometers because we have gone beyond that scale. Now it is being called 20 angstrom, 18 angstroms, etc. We have started talking about angstrom, which is the smallest dimension that we can think of. Now we have to invent new scales that is even smaller than an angstrom. Angstrom is 10 to the power minus 10 meter for those of you who want to know how small it is, right? An angstrom is smaller than an atom. So that's the dimensions that we are dealing with. And with more sophisticated and characterizations techniques available. Before when we joined, like there was TEM and SEM and EDX and all those types of tools. Now there are more tools that really touch and play with atoms, right? Before we had scanning force microscopy that can deal with 2-3 atoms. Now we have resolutions that is even finer than that. So better characterization tools have come, better lithography tools have come. And so it keeps pushing. And it keeps pushing because we have the faith that it is pushable, and so far it has held itself, right? So the key message to you, I actually admire that the students that are sitting here, because the career that you are going to have is exponentially far better than the great career that we were able to have. Because we have taken it, what we believe, to the limits of science, and you are going to take it and push it and say that no, science can be stretched even far. So that's the type of, we need people who have this very innovative mindset to be able to feel comfortable. It's great that, I want to give you one example. when I did my PhD thesis, there was in Cornell, they always bring in one committee member from they probably do a random lottery allotment. The person that came for me, in my committee, is from the music department. And then he showed me, played me something, and then he said, like, how does this work? And he's from music department. And I have no background in arts or music. So all he said is, it does not matter you answer the question correctly or not. But what matters is how are you even thinking about the problem. And the confidence that, hey, I want to address this problem. And if the world, this problem had not been solved, are you going to go in and say, just because somebody hasn't solved, I wouldn't solve too? You're going to say, you need to go try and say, I'm going to put my efforts to go in and solve. And many people may fail. That's okay. Failure is a foundation of scientific success. So I see a large number of students here. I want to tell you one thing very, very honestly. Right? If you read my career, only the very positive things of my career are shown. This guy has these many patents, these many things. For every patent I wrote, I can't tell you how many times we have failed. So those things are not publicly discussed, right? So don't be afraid of failure. And this industry in particular, we have made this vast amount of progress simply because we are not afraid of failure. We put failure as a foundation. We know one way not to do. So then we try the next way. So I think we need a set of people who are not afraid of failing. Failing does not mean doing something, the same failure 100 times. That does not help, right? But learning from the failure and making incremental progress. And so that is the type of mindset that we want in the people that we need working in the semiconductor factories. So anyway, going back, right? So now we dealt with tens of microns. Even that is too small a scale. So we have what is called a substrate or a package that translates this tens of micron into maybe 50 micron, 100 microns. And that is what the printed circuit board, the green thing that you see in any electronics device, that is what it can take. So we started in a nanometer, we moved ourselves into a few microns, and then tens of microns, and now 50, 100 microns. And then it comes into semiconductor where things are dealt with hundreds of micron, which is a tenth of a millimeter, which is a scale that we can even see. You can look at a printed circuit board, you can see the wires running around, but you cannot see the wires running around in a transistor level interconnection. So that's the level of complexity. So you asked about what are the processes involved, and very hard to describe in a very short time frame on what the processes are involved. But at a high level, you take the wafer and you convert it into a semiconductor device. Then you take the device and you call it assembly test or packaging, various terms are used, and you convert it into an actual integrated circuit that you can go buy it from somewhere. Then you need to build an electronic system. You need to take hundreds of these devices and build the electronic system. And by the way, very advanced versions that involve semiconductor assembly test and the printed circuit board subsystem building will also be done as a part of Tata's effort in Assam. So subsystems, then that goes into bigger electronic systems. So in all this, just imagine one thing, this is so complex, so capital intensive, and involves, like typical semiconductor fabrication process involves about 700 distinct process steps. And these are not like I moved from here to there or things like that. Have distinct process steps. There are other additional and support process steps for each of these process steps, which we are ignoring. So typically to make the package, again it is like 600 process steps. Then you go into the printed circuit board assembly, then it's again 50 plus process steps. These many process steps are involved to be able to make what you can buy and do plug and play, and you can have a computer system or other systems with it. Somebody had a comment? Okay, can someone give a phone, please? So that's the number of processes, right? You're talking very, very complex, highly integrated, sophisticated technology to be able to do this. And that's one of the things. Think about how much design is needed for it. Forget about manufacturing. Somebody has to design this. Somebody has to take a product. Can you imagine how these devices will go? It's not like I can go take something and plug and play and see if it works or not. And also it takes millions of dollars to design a product. So I don't want to go play and learn. I need to be right the first time. So you don't even build a semiconductor when you have a product idea. You simulate it. So think about how much simulation capability and talent. We need to be able to simulate a device and say how it would perform before I even made one single device, right? You need to be sure, at least 99% confident that this will work before you go put your $35 million in building an actual first prototype product, and then you have to iterate from there. So these are some of the complexities involved in this industry. Go ahead, please.
Sir, thanks for a very inspiring presentation. I am Professor Girish Sedlur from Physics Department here, and I briefly worked in applied materials in Santa Clara before joining here. My question is regarding the impact of artificial intelligence on semiconductor manufacturing industry. So what do you feel has been the role so far, if any?
Excellent question, right? The question is like the importance of artificial intelligence in this industry. There's a two-way symbiotic relationship here. It's a semiconductor that drives AI, right? Without progress in semiconductor, AI wouldn't progress so much. But without AI, semiconductor wouldn't progress so much. And I'll explain to you the second part, why you need AI to drive semiconductors. I mentioned to you all these complexities. So you don't want to go take a semiconductor wafer, go through 700 steps and then say, oops, it didn't work, right? So you need to be able to collect data and analyze the data. You need AI on the edge because there is so much data to be collected. 100 billion transistors, and you want to collect 10 data for each transistor, right? 1 trillion amount of data. Just before you have not even come to interconnecting it yet. That's the amount of data. So you need to have AI on the edge so that you collect the right data. There is intelligence on what data you collect. Then there is, even after that, even if you say you're 10 times down and you collect 10 billion pieces of data, this is like every second that you are collecting this much data, then you need to analyze this data. So you want to be able to know the defect upfront and make a decision. Do I even take this wafer forward or kill it right there? So that is just one example on where AI could help. And these analytics can help on WIP, work in progress management. It helps with supply chain management. It helps with sustainability, wastewater usage, analysis of that and reducing that. And it will eventually help us make more energy efficient chips, because one of the things that I didn't touch upon is the thermal management. How many of you have a phone that if you drive it, if you're doing a gaming on your phone for half an hour, can you hold a phone? Like you feel the heat? How many of you have had that? Only a few of you? You guys don't feel the heat in the phone? Okay, now the hands come up. Maybe people are sleeping, you need a coffee there. So you see the thermal problem. And if it's a mobile device, if it's a supercomputer, I can go dip it in liquid, right, and do a liquid cooling. Or I could have all kinds of fans, very crazy technologies, right? I don't know how many of you are thermal engineers here? Only one? Well, we need a lot too. We need a lot more thermal engineers. Because think about it, there are all these transactions that happen within a transistor generates heat. That is why there is transition towards silicon carbide and other things for high power applications, high frequency applications, because we cannot manage the heat that is coming in, right? So heat thermal management is a very, very big, complex process. So where AI can help is understanding how these things, and you need to know where to put your hotspots. If you take a silicon device, the entire device will not heat like a heater block. It's not your iron box that you use to iron your clothes. There are hotspots. There are certain spots that generate all the heat, but silicon is an excellent conductor. So it will redistribute the heat very quickly, but there are few spots that are good. So you don't need to provide a solution for the entire silicon chip, you need to provide a solution for those hotspots. But how do you design those, place those hotspots during the design? And how do you optimize it? This is another example of where AI can be used. Essentially, AI plays a very critical role in generating the data, analyzing the data, and characterizing the data, even which data needs to be stored, and making, from the design standpoint, from manufacturing standpoint, from analysis and validation standpoint, AI has not been used to the extent it can be used, in my opinion. And you will see more and more use of AI in semiconductor industry across the platforms, across the design, manufacturing, but also on the facility. Semiconductor facility is very capital intensive. Can I reduce the amount of energy being used there? Can I reduce the amount of water being used there? Gases and chemicals that are being used there. Some of them are nasty chemicals. So we need to minimize the amount of usage. But semiconductor industry is the safest industry. So that shows that how much safety is built into this industry. So AI can help all that. Just to give you a few examples of where AI can play a critical role. So, go ahead, please.
Computer Science and Engineering students of Assam Downtown University. Thank you so much for highlighting the significance of artificial intelligence, and they are very much excited to hear this from you. I also would like to request you to highlight about the semiconductor industry expectations or the skills that they are looking into the graduates, because some of them may be taking 3 years, 2 years, or 1 year to graduate. And then on the other hand, from the students' perspective also, like what are these courses, what are the programs, whereby they can develop some skills so that by the time they graduate, they'll be able to, of course, be at the competitive edge as compared to the peers in terms of getting recruited into the semiconductor industry that is coming up. So thank you so much.
Thank you. How much time do I have left? Can somebody tell me? Another 5 minutes is okay? Okay, so very good question. So, and let me tell you, right, all these complexities boil down to fundamental science. The science is no different. The thermodynamics in semiconductor, the thermodynamics in IC engine, or thermodynamics in a steam power plant or anything, the thermodynamics, the physics, the fundamental physics is all the same. Except that we are dealing to dimensions that are so small that we have to deal with quantum effects rather than like things that are like a continuum. So the challenges are all not new science, but depth of existing science. So my first comment to the students is that be very good at what you are. It does not mean you have to go and do something called semiconductors. If you are a good chemistry student, great. That is one critical talent that we need. We cannot find one person that has all the skills to do semiconductor technology. Just rather impossible. Things have become so sophisticated, it has become beyond our ability to, for one person to have a generic skills across. So that is why we hire domain expert. So be very good in what you do. Whether it is physics, we need it. Chemistry, we need it. Right? You name it, you name any discipline, most probably will need it. So my first thought process, 3-year program, 4-year program, 2-year diploma program, whichever program, be just very good at the foundations of what you're doing. So let's just take chemists as an example. So now you say you are coming with a chemistry background and you are very good chemist, know nothing about semiconductors. The process to walk you through the process of the semiconductor is a matter of few weeks to a few months. We can train you on semiconductor process and generically you can understand what the process is. So, but then it comes down to, we cannot even have the same person deal with all aspects of a process, because there is an equipment part of it, then there is a materials part of it, then there is an operations part of it, right? And so these are 3 different things. You may be a good chemist and say that I really know how to plate, right? Electroplate. So, or I really know how to do sputter. But you may not be the equipment person. So we need people with a different set of skills who can make the equipment and make the equipment robust and talk about, use AI to say, how do I reduce the amount of maintenance rather than go on a time-based maintenance or volume-based maintenance? Can I go collect the data and say, when do I need to maintain? So that is one set of skills. There is me equipment skills. And then you go in and say, okay, I'm going to be a materials person. Then you focus on that materials person. And then my suggestion is, rather than worrying about the big picture of semiconductor, you go deep into it and say, for example, I need a better dielectric constants. There are a few key parameters. Suppose I'm dealing with a dielectric material. What do I need, right? I'm going to have transmission line through it, and I need two transmission lines that are so thin by themselves and so close to each other. And they are going to operate at extremely high frequency. We are going to push electrons. And then the first thing is there's going to be skin effect. When they are going at that higher frequency, then there will be skin effect. Then that implies that if I'm a chemistry person, when I build this transmission line, I need to have a perfect edge, atomically smooth. If I have any roughness on the edge, then the skin effect will make it a very worse and lossy transmission line. So can you think about how do you build, how do you etch, or how do you fundamentally make a transmission line that has a very perfect atomically smooth edge on all four sides? Then this transmission line is sitting on a dielectric. It needs to adhere to the dielectric. And you know that how many people have dropped your phone at least once in your life? Come on guys, be honest. Okay, I don't think this is true. I only see like 30%. I'm sure 100% of you. Otherwise, why do you even buy a phone cover? So, sorry? 100%, right? So people drop your phone, and that's going to add to a mechanical shock to this transmission line. Forget about electrical performance and all these things. There is mechanical shock that this has to withstand. So then you need perfect adhesion to be able to withstand all these. So now the adhesion is good. Then the dielectric properties has to kick in. When signals are moving in at that high frequency and the transmission lines are so close, you don't want to have crosstalk. So then this dielectric material is the one that's going to stop this crosstalk. So you want very high dielectric constant. How to get very high dielectric constant? Make it porous, put air into it. If you put air into it, it becomes very weak, it will break. So how do you make it like very flexible and elastic and have a very high dielectric constant? Very good dissipation factor, right? And it has to have very good adhesion. Right? So these are all type of foundational things that you will do, and you are contributing to furthering the cause of semiconductor. Very rarely in your life, gone are the days that somebody will come in and say, I worked in lithography, I worked in tracks, I worked in wet, I worked in dry. Absolutely no way you can work in all of these. Right? Maybe you would have heard somebody talk about all these. The world is so sophisticated now that I need somebody just focusing on how do I make this dielectric material adhere to my transmission line. You make a career out of it, you would have done good for yourself, you would have done good for the industry. So with that level of sophistication, and now that you understand the complexity, be very good at what you are. And then we need, because we don't want people, I don't mean it in a very bad way, we don't want people just with technical skills coming and handling equipment that are tens and millions of dollars, right? So we need something in between. So for you to have your foundational technical skills to practical engineering skills. So that is where we were talking to all these academic institutions, and that's my motivation to be here today, to talk to academic leaders, and that gap has to be bridged. One way to bridge is you dump it on us and we go put a 1-year training and do it, but we are not educators, right? Ideally, we would like people, we will teach you the application, but the fundamental aspects we want the education institution to teach. So we would like to bring in courseworks that are tailored to various levels of employment that are needed in a typical semiconductor factory. We need people, suppose I'm going to be a technician. I suppose I'm the bottommost technical guy in the factory and I'm just going to go run tools. Even there, the person who runs the tool is different from person who maintains the tool, is different from person that programs the tool, is different from person who does unscheduled maintenance and upgrades of the tool. Right? I mentioned to you the rate of innovation that happens in this industry. So you cannot buy a tool today and say, I'm good for another 20 years. This tool will work. The tool will work, but technology will progress so much. Either you have to upgrade the tool or you have to bring in new tools. So basically, the right at the bottom person that will come in still needs to be educated on what is a clean room, right? Because you cannot walk like this into a semiconductor factory. You need to wear bunny suit properly. You have to make sure that you are grounded, your body is grounded before you enter a semiconductor factory. After all the governing protocols, we check you for ESD, electrostatic discharge, right? You have electric particles on you, then you will kill a semiconductor. And even then, we never allow you to touch a semiconductor, by the way, even if you work inside our factory. But you will be grounded. And the whole flooring of a semiconductor factory will be ESD grounded. And it will go to a huge ground at the end. But you need to know all these, that you are being, what are the sensitive aspects of it? What are the clean room protocols, do's and don'ts in a clean room? What are the ESD requirements to be successful? And what are you cannot take a paper into a clean room, right? Because if you take a paper and by accidentally you write with a pen on a paper, that how does a pen create a mark on the paper? By leaving particles on the paper. And one of that particle falls down, our semiconductor will die. So you cannot go, there are specific clean room papers, there are specific clean room writing instruments that you need to know. You cannot take your pen from here and say, this is a beautiful, whatever is a high brand pen, and go write with it inside a clean room. So we need to educate the technicians on all that, right? So that is one aspect of it. That's like technician training. I believe that maybe in a 6-week curriculum, we can train people like that. Then I'm going to ignore a few other things, right? Similar to that, to program a tool and everything, 6 weeks, 8 weeks, we need to teach. Then engineering. People need to understand the science behind it, right? Of course, you understand how thermodynamics works, but how a semiconductor, from a source to a drain and gate, and how does it work? That electronics piece, I can wake you in the middle of the night, maybe you know how to do it. But to be able to build it and to be able to interconnect it, you need to know there is a certain, I'm going to say there is more art to it than to science, right? Just with the fundamental scientific knowledge you cannot go do. So then we need to educate, how does the process work? We need a set of engineers to understand the process optimization. Can you believe we never allow people to upload a process recipe by themselves? Nobody in a semiconductor operational factory ever touches a recipe. It is so proprietary. It gets stored in a server somewhere. When the part comes in, it will scan the wafer automatically. The computer will know what wafer is coming in, what process needs to be done. The computer will upload the recipe by themselves, and the operator only will have to watch and make sure. So it is only in extreme cases that an operator will have to go intervene with a process recipe. So developing the recipe, that requires probably like 3 to 6 months of training to be able to even understand each single process, right? And if you want to be trained in 2 or 3, it's like a year program. So we are requesting academia, can we put the next higher level of curriculum for entry-level engineering, graduate engineering people and master's level people, and to be able to develop this kind of talent to build recipes. Then we need a next level of talent, and probably it's not something that's easy to create in academia. You need hands-on experience to do validation engineering, right? You just need to have done that. And so we are working with certain academic institution to go in and say, can we create like a 2-year program where 1 year you get educated with all the crash course curriculum that you will have through a regular master's program. Can we send you to some Taiwan or United States or somewhere for a year? You go work hands-on in a real fab, in a real manufacturing environment, and come back with those skills. So these are different types of ways by which we need to train the skill sets. So from technician through engineering, through senior leaders, through validation and other integration engineers, the talent levels are different, and the training durations and the training depths go very significantly. So what would be very helpful is that we put don't worry about like being yielding fab and things like that. Put small micro fabs where students can go hands-on. Some of you know that I worked at Cornell. And my claim to fame is that I worked in Cornell nanofabrication facility, where we go ourselves, we run the tools ourselves. And I tell you, honestly, out of 1,000 times we do something, if we are one time it works, we are very successful. So the yield is very low, but does not matter, but we know how to work with our hands. We tweak the tool, we see how the tool responds. And every tool is a human, like a human being. They don't respond the same way, right? So you need to be very intricately tied to your tool. So for example, even tool engineers are typically PhD people, because they need to know their tool really well, and they need to have a sync with the tool that I moved this way, I moved by quarter inch, then the tool performs like this. So that level of sophistication is needed, and so we need training at all levels. And so at this point, don't worry about it. Just do your program really, really well, right? My job is not to teach you fundamental laws of thermodynamics. That you learn in your school. Then we will see how to bridge the gap between what you have and what we need through various levels of curriculum. And that's the discussion that academia, government, industry needs to participate and bring that thing in India. I want to give you a reference from United States where I'm more familiar. And so in United States, the government came in and said, we are going to invest in nanotechnology. So they put 6 centers, Cornell, UPenn, Santa Barbara, Harvard, there are 1 or 2 more, right? So they built these nano centers where students were allowed to work on the tools by themselves and learn the process. And so the 100 engineers that came out of that program every year were highly employable. So I think like in India, we need to think about how do we bring these things, right? Giving instructions like this or even putting more PowerPoint slides and everything are easy, but the proof of the pudding is in the eating, right? I would like people on the ground working with their hands. Does not matter if it worked or not worked, but the process of your working by yourself and building something, even if it does not work, you learn a lot more than sitting here on how much your videos and PowerPoint that we can show you. So how do we build that kind of skill center, right? Micro fabs across various parts of the country so that we generate this large talent. Because Tata's investment is just the beginning phase. There will be more investment from Tata's and other people, right? India is expected to become a semiconductor hub, and we want to be a leading player in the global value chain. And the other aspect of this is that we should not be arrogant enough to think that just because India has a strong set of engineering talent, that we can do everything across the value chain of semiconductors. This is so complex. No country in the world has done it. So we should think about what are our core competencies and go make that and make it really good, right? So for example, even today, for example, in our factory, most of the tool sets comes from Japan. So Japan is very good in equipment. Then there are companies that focus on countries and companies that focus on materials. There are companies and equipment that focus on design and design tools, right? So we need to think about what our core competency is and make that our competitive advantage when we go and fight with the industry. Because one other statistics that I wanted to show you, not to depress you, is that if you look at 90 nanometers, there were about like 45 players in the fab. And then I go fast forward to 5 nanometers, there are 3 players in the fab, right? And also like even that 3 are struggling. So it is not an easy thing. So we need to focus a lot more on curriculum and practical curriculum. And I want to see more people working with their hands, irrespective of whether things work or not. That is far better than more and more like curriculum that goes through PowerPoint and videos. So that's my request to you. Hopefully, it was a long answer, but hopefully it helped. Thank you. So should I cover anything else? I don't know how much time. Is it okay? Okay, very good. So hopefully this thing was helpful. Can I take a question? Can I take a question, or we don't have time? Okay, apparently we have a panel. Okay, we have a panel discussion, so hopefully we can take questions there. But I truly appreciate the patience, and hopefully I've been able to communicate at least the basics of this industry. And Thank you. So collectively, we will do it great for the nation and for the world, and more than anything for our customers, global customers. Thank you very much. Thank you.
Thank you so much, sir, for insightful thoughts and motivating us. Now I request Professor Rajiv Ahuja, sir, to felicitate Sri Narayan Kanwar, sir, Secretary, Government of Assam. Moving ahead, I request dignitaries to unveil brochure of semiconductor facilities and expertise and research park newsletter of IIT Guwahati. I would request Professor Ratnajit Bhattacharya, sir, Head of Mehta School, IIT Guwahati, to facilitate the process.
Thank you, sir. Ladies and gentlemen, esteemed guests, and distinguished members of the academia and industry, it gives us a great pleasure to welcome you to the momentous occasion of the Memorandum of Understanding exchange between Indian Institute of Technology Guwahati, Indian Institute of Technology Ropar, and Electronic Sector of Skill Council of India. Today marks a significant step forward in semiconductor technology, skill development, innovation, and fostering of startups. The collaboration between these esteemed institutions and ESSCI is poised to create a robust ecosystem that nurtures talent, fosters innovation, and drives the semiconductor industry forward. As we sign this MOU, we look forward to a fruitful collaboration that will enhance skill development, spur innovation, and create a conducive environment for semiconductor startups to flourish. I want to express my sincere gratitude to all of us who are involved in making this collaboration possible, and warmly welcome to our guests from IIT Ropar and ESSCI. Now I request Ms. Abhilasha Gaur, CEO of ESSCI, onto the stage. Now I request Professor Rajiv Ahuja, sir, Director of IIT Guwahati, and Ms. Abhilasha Gaur, ma'am, CEO of ESSCI, to exchange MOU. Exchange of This MOU is exchanging between Indian Institute of Guwahati, Indian Institute of Roper, and the Electronic Sector Skill Council of India. Now the exchange of MOU between IIT Roper and CEO of ESSCI.
Let's proceed for the panel discussion. I'm honored to welcome you to the panel discussion on Semiconductor Horizons in Assam, Technological Empowerment through Skilling and Innovation. Semiconductors are the backbone of modern technology, powering everything from smartphones to advanced medical devices. As Assam seeks to advance technologically, the semiconductor industry presents a significant opportunity for growth and innovation. Today, we are privileged to have esteemed panelists who are pioneers and leaders in their respective field with us. Now, I request Professor P.K. Iyer sir from IIT Guwahati to moderate the discussion.
Very good afternoon to you all. Once again, welcome to this special session. We are having an interactive session. We had a very lively talk by our chief guest, Dr. Charan, and I'm sure the audience would really love to do that, continue to do that. So I request all the students sitting in the last rows here, please come forward. It's easier for us also to go around with the mic. I request you all to please come in the front. If you all can come, this side it's completely empty. All the students sitting on the left side, the back rows, please come forward. I request you all to please come forward. Even from this side, you all can come forward. So we'll take approximately around 20 to 25 questions. We have around 45 minutes time. And we want the students to interact with the industry experts, Director of IIT Guwahati. We also have people from the skill development. And I'm also going to invite few more dignitaries on the dais for interaction. So we have with us Mr. Manvendra Pratap Singh, MD AIDC. May I request you to please come on the stage, sir? I also request the Vice Chancellors of USTM, Royal Global University, and Bodoland Universities to please come on the dais for the interaction. We also would like to hear the perspectives of the role the private universities, the state universities, and of course the academia and the skill development council, they play or they would like to play for the students. Once again, the students, you stood up and again you sat down. I request you all to please come in the front. Yeah, from this side. Please come in the front. Keep walking, keep walking. So I welcome all the panelists for this special session. I'll request Professor Rajiv Ahuja, Director IIT Guwahati, to preside over this session. All the guests who just came on the dais, I request them to give a 5-minute overview of what they would like to do with their universities, with their organizations in promoting this specific industry, the semiconductor industries, and how Assam and the Northeast can be brought into the main loop of bringing awareness, and then how, as Dr. Charan mentioned, the need for basic education, basic skilling to the level of sophistication that any higher academic institute can provide. So I think it's a collective effort that we all need to play to bring awareness and to help this industry grow, not just in this region but also across the country. So Professor Rajiv Ahuja, I request you to please preside over this function. Thank you.
Okay, thank you. We can start now, and thanks Professor Iyer. And I think please, now student, please can you please sit down? And we can start this session, and you have a lot of other questions also which you cannot ask with Charan, Dr. Charan before. Now you have a chance to ask that also. And since this plant is coming in Assam, so I can see that there are a lot of questions from your side, and what is the future, and how this part of the country will grow with this new plant is coming, and what are the roles of as a student or as a faculty or as a researcher you will play a role in this kind of plant which Tata is bringing here. So as he already mentioned, this is a very high-end industry. It's not like a normal industry. And he talks about the Moore's law. Of course, he wants to go to angstrom level also. I want to tell Dr. Charan, angstrom is a professor from our department. So it's good that we are going to angstrom level. I can tell in Sweden that we are talking now on angstrom level. And so this is a right opportunity where you can interact. This kind of opportunity you will not get any other place, where you can directly talk to the stakeholders as a student, and you have the right forum now. You have a lot, you will be very curious. We always say that what Nobel Prize, when I always talk about Nobel Prize, when we talk about semiconductor physics, you can see how many Nobel Prize in physics has gone for semiconductors. So it's a never-ending story, and so wherever we need a semiconductors, you have more chance to get a Nobel Prize. So this is and Nobel Prize encourage research driven by curiosity. So we have to be curious. Otherwise, we cannot drive a research. We always say that research and innovations are connected. So you want to be most innovative country in the world, you should have very strong in the basic science also. So without basic science, you cannot be an innovative country. So we should put our foot on the fundamentals. And as Dr. Charan already said that in one line, maybe you missed it, actually IITs are set up for science-based engineering education. And you can see that why IITs are doing great. This is because this is the part where science is an integrated part of the technology. So science-based engineering education. So with that, I will not take you much of your time. And since the experts are here, and they are vice chancellors from different universities, of course, Dr. Charan is here. We have a person from the ministry also, and people from who are working for the skilling, especially in the area of the semiconductors. We are all here. So I keep this forum as open, and I will start with Dr. Charan, and he can give some overview, and then you can ask some question, which I heard that at that time there were some few questions still left, but you can answer it now.
Thank you very much, Honorable Director Rajivji. So rather than I've said a lot, so I don't want to keep adding to things, and so maybe let's just go straight into questions. Should we introduce the whole panel and then go to questions? How should we do it, sir? Okay, so I've been introduced, so I will give it to Rajiv.
dignitaries on the dais, respected professors, head of the institution, ladies and gentlemen. I am Manvinder Pratap Singh. I am looking after Assam Industrial Development Corporation. I am Managing Director. So this facility which is coming up in Jagi Road is actually looked after by AIDC. So we are providing all the infrastructure and other support to make this dream comes true. And since last 1.5 year, we are actually thinking and planning, and it started even before that when first time this paper mill was actually taken over by Government of Assam for a bigger purpose, and we actually discontinued this paper mill, auctioned it, and we prepared that space for some mega investment, mega industries in Assam. And then Tata comes, and Dr. Charan for last 1.5 years, I met first time, and then when I listened about this project of manufacturing chips in India, so it was an eye-opener for us also, because many things are associated with this complicated technology, and the requirement of our country to be there at the right time and manufacture those chips in India is very important and strategic initiative which Tata has taken up, and Assam has taken a big leap forward in technological advancement and even in industry side, and this is the I think this will be one of the biggest achievement of Government of Assam, and for future of Assam it is, I think, as Dr. Charan was describing about the Malaysia, one city in Malaysia has turned into a big center for semiconductor manufacturing. I think next center will be Jagi Road. In coming years, I think we will be able to make it a known name in the world map. So hopefully we will be able to do this, and we are here to support this initiative from all the point of the support and the infrastructure, and whatever is required from Government of Assam, we are there. Thank you.
Thank you very much. And I am Professor G.D. Sharma, Vice Chancellor, University of Science Technology, Meghalaya, and President, Association of Indian Universities. We have largest number of universities association in the world and second oldest university association in the world. So when this announcement came that one of the semiconductor industry is coming in Assam, that was the most welcome to this Northeast, that such a sophisticated industry is coming for the first time in Northeast. And I take this opportunity to thank our very dynamic Chief Minister of Assam, Dr. Hemant Biswa Sarma ji, who has taken this lead to bring this kind of facility, particularly to the youth, to provide such opportunity of jobs and also to make utilization of their talent. The reason was that in Northeast generally we do not have such sophisticated industries so far. Therefore, most of our talent is going to other parts or abroad, and therefore the Northeast is not able to utilize their talent. I feel that this will help to retain them, to also create the thought process of our institutions also. That now in addition to the basic degree programs which we are having at present, we will also have this applied part. I am also the member of the Indian Institute of Science, Bangalore, where Dr. Chandrasekharan is the main chairman of their committee of this, where we are member, and they have started MTech. Our university is planning to start the AICTA program on semiconductor. First we will go for diploma and then degree program. Therefore, the students of Northeast will get chance. Our university is already partner in Sathi program submitted by IIT Guwahati, where the application of the knowledge, which is generally not so much extensively used in this region, it will be used for the industries. We have identified certain areas, and in those areas, our students will also get the opportunity to make use and especially develop that kind of skill which they can apply. Today, the time is there, as Dr. Charan has said, that how you can utilize the content of your course syllabi, curriculum which you have learned to create something, to create knowledge, and also how this knowledge can solve the problem. That is most important thing, that the education has to take part in solving the problem of society, and that is how it will create lot of the jobs as well as opportunities to apply their talent. So now we are shifting. Recently we have signed MOUs with NASCOM and other industries where new skills are coming. These are of having different durations. So along with the long duration of the courses, the short duration courses will also add to the knowledge creation, and also motivating students that you have to do such courses which you can help yourself for creating the knowledge and creating the new patent. Recently, our university, when it has taken this kind of the things, has published 120 patents. So I look forward the support from the Tata companies and also Dr. Charan especially. And I thank Dr. Ahujaji, Director of IIT, for giving us this opportunity. Thank you very much.
Respected DICE members, professors sitting in this conference hall, students, dears, I am Dr. B.L. Ahuja, Vice Chancellor of Bodoland University, Kokrajhar. As we know, this Bodoland was having certain problems till 5 years ago. Now the problems are sorted out, and it is now very peaceful and very progressive part of the Assam. So I am just talking on behalf of the small state universities, because Assam has about 20 state universities, and out of these state universities, 10 universities are just developing. We have to bring them to certain level, and the challenge is, with limited facilities, how to help and how to get jobs in Tata Semiconductors, that we need to see. You see, instead of doing sophisticated experimental work, one can also do very simple calculations if you have very good computational system, and that is the band structure calculations, or say electronic structure calculations, or DFT calculations. So in such calculations, basically what you do, you solve the Schrodinger equation using different exchange and correlation potentials, and then you try to find out electronic, optical, structural, thermal, all type of properties of semiconducting materials. So basically, you fabricate the materials without involving chemicals. So this is green engineering aspects of science. So that type of work can easily be taken in the state universities, which are just developing, like Bodoland University. We have MSc Physics, MCA, and other parts also. So the students, we can train in that part. And further, I want to have some help from the Tata group, so that some good computational facilities can also be given to the state universities. And I'm sure that these universities will do a lot of work for Tata Semiconductors, because you see, there are two parts of science. One is experimental physics or experimental engineering, and another is theoretical. So just on the basis of hit and trial, if you try to develop new semiconductors with certain properties which are required for nowadays electronic devices, then you have to do so many permutation combinations, and those can easily be done using band structure calculations. So those who are here from the state universities or the students who have limited facilities, they can also do good science, good engineering, good physics, and they can also get jobs in the Tata Semiconductors. This is what I believe. And I also need assurance regarding this from our honorable member, DICE member, Dr. Charanji. So friends, I'm here with you for further panel discussion, and in case you have a scarcity of funds, and then how to meet out or say how to work out within the limited funds and contribute in the semiconductor materials, that part I will be happy to answer. Thank you.
Good afternoon, everyone. I'm Dr. Abhilasha Gaur. I'm the Chief Operating Officer of Electronic Sector Skill Council of India. So we work with Ministry of Skill Development and Entrepreneurship, as well as the key implementing agency for the capacity development programs for Ministry of Electronics and Information Technology. So our mandate is, we started in 2012, and for the capacity building for the electronic system design and manufacturing. So till now, around 1.9 million candidates in around 602 districts have already been trained into various domains of electronic system design and manufacturing, which includes consumer electronics and IT hardware, solar and LED, communication and broadcasting, industrial automation, electronics manufacturing. Semiconductor and components is one of the domain where a lot of focus we are seeing in from last few years. And we already have developed around 20 qualifications. So our mandate as Electronic Sector Skill Council, as an awarding body, is to, you can say, to standardize the curriculums, which are short-term training programs, which ranges from 300 hours to around 900 hours, and which can come up on a foundation level degree. So this foundation level degree can be a diploma in engineering or a bachelor's or a master's in engineering. So these 20 programs, few are in design, few are in industrial safety, quality, as well as for AT&P. I'm really excited to be here and looking forward for more interaction in this workshop. Thank you so much.
So we can start discussion, and we can take first the questions now from the audience, and if they have any curiosity or they need to answer something from Dr. Charan or anybody in this podium, please, you are free to ask now the question.
Yeah, my name is Basavanand Goswami. So I am representing Nav Prayukti Private Limited. We are a startup. We started in 2022. So my question is to Gurumurthy sir, that how do we look forward to this development, and what are your expectations for us, for new startups like us? So we are basically into electronic system design and development.
So your question is, how do you do business development, correct?
Yeah, yes, that's the
good question. So before we worry about business development, we need to have technology and affordable. We need to know it is affordable. We need to have demonstrated quality, reliability, and we need to be at scale, because we cannot go to, semiconductor is a very large industry. Things are done in millions and millions of units. So once we have all that, that's the foundation for going and approaching customers to do business development. And our customers are semiconductor customers, they look for innovation. So we also need to be able to show, we have in-house very strong R&D team, and we have very strong partnership with academic institutions. So things that are far out research, as well as things that are near-term research, are all being appropriately carried out, and we have a cadence of roadmap for technology. So these are all foundations before we even think about approaching customers. And then in terms of going to business development, there are multiple strategies that each company can have, but foundationally it depends on like what type of customers you want to go after. Like semiconductor companies, you can have large volume and low mix. Like typical IDMs, integrated device manufacturers, they have the approach of they have very few number of SKUs, but they have very large volumes of it. Whereas if you look at commercial electronics, these are low volume, but very, very high mix. So we need to, I'm not talking specifically about Tata, any company has to decide what is their business strategy. And that determines what type of customers you go after. Do you go approach a large IDM, or do you go after medium and small scale partners? But we, specifically about us, we as a pure play semiconductor assembly test partner of the world, and we are open for every customer, irrespective of their scale, and whether they are small customers or very large customers. And also another aspect of business development is we need to be fairly clear on what market segments we want to go address, whether we want to be in automotive and industrial, IoT, commercial, communications, high performance computing. The needs of all of these, well, foundationally the technology is the same. The specific needs of these are quite different. And in some cases, you need to enable yourself with right standards, business standards. For example, you need, for automotive, you need IATF standards. So we need to be certified on those IATF standards, which typically takes a year plus. So the next approach is like what business segment do you want to go address? So these are some of the foundational things that we need to do before we go approach customers. And those are all part of business development strategies. Hopefully I answered you.
Yeah, so basic specific.
What are the alliance industry that can grow?
Yeah.
There are many, okay, the question was what are the alliance industry that can grow along with semiconductor? And there are so many. There are equipment manufacturers, right? The ecosystem consists of not just a semiconductor manufacturer, there are equipment manufacturers. All the tools that we put in, very few tools we make by ourselves or we modify by ourselves. Most of the tools come from very large players. And today, unfortunately, most of the players are outside of India. And in order to have supply chain resilience, it's better to build the ecosystem in India over the years. Either we need to attract global players to be co-located, near located, or somewhere located in India to support us, and other manufacturers of semiconductors that will be in India in the future. And or we need to motivate local manufacturers to get into semiconductor equipment manufacturing. Similar to that is materials. We need dielectric materials, printed circuit board materials, plating line, lead frames, multiple materials. So we need materials manufacturer as part of the ecosystem. Then we need design partners, right? The EDA guys, the Cadence and Synopsys and so on. So we need the design part of the ecosystem. And then we need infrastructure, right? Airport infrastructure, ground logistics, air logistics. I mentioned to you what is the cadence in which our customer expects products to be turned around. So the infrastructure, the transport infrastructure needs to be in place to be able to drive us and make us be successful. So typically the way you look at is if there is one job in the semiconductor industry, there are like 5x the amount of job in the ecosystem. So that's the rough ballpark picture. Thank you.
Sir, I have a question.
Can I? May I? Go ahead. Yeah, good morning to everyone. Myself, Monali Dr. Soikia. I teach in a state government college. It is an autonomous college, and we have PG department. I am a faculty from chemistry department. So as I can also feel that we have lots to do, chemistry people, we can do a lot in the semiconductor industry, and our syllabus are also designed in such a way, like I teach physical chemistry, so these are a part of our syllabus. And now we are teaching some molecular devices also. So I am telling the students it's not only of chemistry, need to know a lot of electronics, which I myself do not know, a lot of engineering, so we have to give some basic ideas. So how we can, how can our student get employment there, or do we have to give them special training or training at this industry for semiconductor industry? So they have the basic idea, as you said, they have the basic concept, but they need to be trained up.
Sorry, I couldn't understand the question.
Yeah, actually, sir, but chemistry students, we have at our college still MSc PG level. Okay, so how can we involve our students in that semiconductor industry coming up at Assam Jagiro?
Okay, so let me repeat the question to make sure at least the panel understood the question. So you're saying specifically about chemistry, how can they be
chemistry student, I am targeting the MSc students specially.
Okay, thank you.
Yeah.
Anybody else? I know we have a lot of key panelists. Anybody else wants to?
Thank you very much. Actually, now our autonomous colleges, universities will have opportunity to design, add those courses which will be relevant. And under UGC, now in NEP 2020, there is a scope that 40% courses can be taken from other universities where these courses are there. Courses related to material science, the chemistry department can select the course which can be given to those students who are interested. Courses on design, engineering, or only those courses which are more related on data science. So such opportunities will also come to our universities and autonomous colleges now to modulate, bring the changes in our syllabi which will be relevant to such kind of the industries. Because so far we are having basic courses, as you rightly said, the chemistry, physics, or zoology, botany, like that, because there is a need for such courses for the colleges, for the universities, for the schools, giving jobs, etc. But now this applied part will also emerge, which have to be changed by our autonomous colleges and the universities. I give an example that because there were not many industries, these three industries are coming in semiconductor. The IIC, Bangalore, they are making design and selling to Taiwan, semiconductor industry. So I was surprised that, you see, the talent is there, but there was no scope in our country. Now there will be scope for our country. So now what they are going, that they are going to take this to the stock market. Whoever will give more money for their design. So you just see how the education is shifting now from traditional way of our teaching learning to the applied way. Thank you.
Yes, sir. One other comment that I wish to add to Professor Sharma's comment is that for gases and chemicals are very critical for the semiconductor industry. So people with chemistry background, I've seen a lot of people do very substantial contribution towards developing these process gases, developing these chemicals, as well as materials like dielectric materials, photoresist materials, and sensitivity to various frequencies of light, and magnetic materials, thermal solutions, thermal interface materials. So there is a lot of engagement with people with chemistry background. So what may make sense is, like maybe some other time we should have an opportunity so that we can get into specific aspects, because it's very hard to summarize all these in a short time. But there is a huge scope for chemistry people, so I look forward to more chemistry students joining us and working along with us. Thank you.
Sir, I am Dr. Sarkar from Jagrut College. So we are degree college only. So what should be our role as a faculty to train our students to get this opportunity? Please, sir. It is a degree college only.
Actually, Professor Sharma already answered to your questions. So we can run those semiconductor related courses. You have maybe even your degree college, you still have a department of physics and chemistry. So for when we talk about semiconductor, physics is also going to play a key important role. So you can start the courses with a more specialization in semiconductor or semiconductor technology. So that will be useful. Then they can be further skilled institution like IITs, so that we can give them more skilling courses. So this is the basic background they should have.
I'll also just add to this. AICT has launched 2 programs. One is VLSI Design, that is a 4-year program for BTech, and IC Package Engineer also, so that's a diploma program. Almost 300 institutions across India have already enrolled for that program, where the complete curriculum and support and various almost 70 faculty development programs have already been executed. So you can look forward more details for those programs, and in case you would like to start, you can do that also.
Good afternoon to respected panelists on the dais. I am representing Pandit Deendayal Upadhyay Adarsh Mahavidyalaya, Turungia from Bongaigaon district. Sir, I have been really fascinated by your deliberation, Dr. Gurumurthy sir. Sir, as we hear the word semiconductor, then the concept really comes of physics and electronics. I am from a life sciences background. So the students of life science background, such as zoology, botany, molecular biology, microbiology, so how can these be related to life sciences? As I can recall, there are lots of ongoing research papers, researchers on the use of semiconductor-based chips for DNA sequencing. And these chips are based on some micro wells in which the templates are loaded, and then on the basis of the polymerization, the hydrogen ions are liberated and that are detected to find a sustainable and cost-effective solution to this complex DNA sequencing thing, which is a really milestone for medical sciences and pharmaceutical industry. So sir, as we have already talked about the allied industries that will be coming up, so if semiconductor chips and wells can provide this cost-effective alternative to the hugely expensive pyrosequencing things in the biomedical and pharmaceutical industry, so I think this semiconductor plant, if it is developed, then it can be a boost to this biomedical, pharmaceutical, life science background students as well. They can also get inspired from this particular initiative from the government. So what will be your take on it, sir?
Thank you. So let me comment, and I'm sure that more delegates could also comment. So you're right? Semiconductor does not only stand for computing, right? Semiconductor is a foundational capability that can be used across life sciences, in automobile, in many applications. So from that standpoint, even today, pharmaceutical and semiconductor use extensive amount of computing. DNA sequencing are all done not by humans, right? It's all done by computers, supercomputers, and other several programs. And so there are 2 different aspects, right? One, people with life science background can take a semiconductor and do an applied application to their respective field. There's a huge scope for that. That is one way the students can help. The other thing is, like, in life sciences background, semiconductor industry is very sensitive to sustainability, I mentioned. So what is the type of positive impact that we can have on people and the environment and so on? So there are people that work from life sciences background actually in the semiconductor industry to promote that. So those are the 2 ways by which I think these 2 disciplines can help each other. Any other comments?
Sir. Suresh. Hello, sir. So my name is Arnab Burman, and I am representing a startup, DSRL.
based out of IIT Guwahati. So we are a deep tech startup working on defense, space, and oil and gas. So my question too is in applications of special electronics like high temperature electronics, high temperature semiconductors, or radiation hardening. So in that direction, is there any scope of startups like us to like in business development or probably in co-development? So how is there any scope in that direction?
Your question is there any scope for oil and gas?
In the special electronics like high temperature electronics, which is a little bit different than current.
So scope for electronics application in oil and gas? Or
In high temperature electronics.
High temperature?
Yeah, space electronics, yeah.
So, okay. So let me, I mean, electronics, we design through certain reliability conditions. That's why I said one of the key things is which market segments we want to address. If it is aerospace, radiation damage and those things are very critical.
Right.
Oil and space, subjectivity to corrosive environment like oil, we need to be able to reliable to that. And if it is life science space, blood and other bodily fluids, right, it needs to be resistant. So when we decide which application that we go on, that's based on which customers approach us, and we will support all of them. And so the customers determine what is the application and what are the reliability requirements. And what we do is we take these broad requirements coming from the customers and we envelope it, because we cannot do 1 million quality runs and 1 million reliability runs. It will be very uneconomical. So what we do is we take the feedback coming from customers from various market segments and we categorize it into 3-4 buckets in terms of quality requirements and reliability requirements. And we do our qualifications according to those requirements, and that is how we certify. And also, there are market industry standards in various disciplines, like in automotive, etc., that it clearly says what are the specifications and reliability criteria for an autonomous application and different levels of certification. So that is how we approach when we go do certifications, qualifications. Not to individual customers, but we take individual customer feedback and play to an envelope certification.
Okay.
Thank you.
Good morning, sir. I am Mohammad Hasnat Zaman Shoykut, a student from Assam Downtown University. So my question is, what will be the impact of quantum cellular automata for quantum dot cellular automata on semiconductor industry?
So let me again comment on this.
Actually, as I said earlier, so far our universities and colleges, we are having more knowledge intensive courses. Now there is a scope in each branch to connect the application. How? Because as Dr. Charan Gurumurthy told, that semiconductor area is a multi-facial or multi-subject area, not one. So here, how you want to develop, as a life science student also asked, that if they are working on nanotechnology and a number of chips are being used now in monitoring the health related things, similarly quantum physics have been used for the semiconductor and other things already, because it can create a better ways. So how we go for it? So far in our Northeast, we are not having that kind of the technological development, as he said, that not now nanometer but angstrom and nano angstrom. So these are the things which needs to be have the facility, but the knowledge, the papers or these things can be had.
Sir, my question is that many researchers has told that.
Yes, can I answer your question, please? You see, whenever you talk about quantum dots or very small size particles or thin layers, their property drastically change from the bulk part of that particular matter. And even say if I have one layer, it may have indirect band gap. If I have two layers, it may have direct band gap. If I have three layers, it may have different kind of band gap. You see, that depends upon, particularly in case of nanos, what is the surface to volume ratio. So how quantum effects are influencing the exchange and correlation potentials. Accordingly, the electronic properties change actually. So in case of silver nanoparticles, if you have different nanoparticle size, so you will have different properties. If the way of preparation is different, you can have different properties. So it's very difficult to say, okay, by using this particular style of developing nanoparticles, I will have the same type of properties while doing it with the another kind of development technique actually. One is if you are doing through chemical, or if you are doing just by ball milling or something like that. So you may have different type of electronic properties, optical properties, bulk properties you can have in different ways. So just keep on doing whatever you are doing in your college or institute. So if you have nano, see the procedure, how you prepared it, how quantum effects are influencing it, and then you can suggest the application of that particular type of materials. So this is in general answer to your question.
Sir, actually my question is that sir has told about Moore's law. Moore's law, many researchers said that Moore's law will be limitation in future, and researchers are interested in quantum technology. If quantum technology is available in market, will it impact to semiconductor industry? My question is this, sir.
Okay, so your question is, eventually quantum technology will come, and what will be the impact of the current semiconductor technology? One, you are right, it will come, right? It is in its nascent phase, but the potential of the quantum computing is very, very big, and it will eventually come. All the challenges will get addressed, just like semiconductor challenges were addressed long back. And there will always be a transition, right? And so semiconductors for a foreseeable future, I can say next 5 to 10 years, which is a very long time, semiconductors will play a role. And quantum computing has advantages over certain type of computational aspects, right? So I firmly believe that even when quantum, the challenges or current challenges related to ability to scale a quantum realm is all addressed, even then this will play a very complementary role to semiconductor, the current semiconductor approach. And so it will be a very long term into the future, foreseeably like far beyond at least many of our working time to see that semiconductors will go away. I don't expect semiconductor to vanish. So it will continue to play a significant role, and quantum will play a complementary role there. Thank you. That's my opinion.
Hello.
Nobody knows.
In addition, I also recommend you go through the research papers of Professor Rajiv Ahuja, maybe several hundred papers he has on the quantum dots and nanoparticles and layers. You got a lot of idea from those papers, and I'm grateful that this institute has director like Professor Rajiv Ahuja.
Hello.
Okay, I think we can go take one more question, because then we have to conclude, because there's a coffee or tea waiting outside, and then we have to ask after that also we have to start another session also before we going for lunch. So we can take one, maximum 2 questions only. So
yes, sir. Hello, sir. This is Mohammad Mukibul Islam. I am the CEO and the co-founder of Hopuntech India Private Limited. We are a local-based startup company. We started in 2022, and we're a software company. So my question to Dr. Charan Gurumurthy sir is, what are the opportunities for entrepreneurs who are based locally? Is there any opportunity for this semiconductor mission which you are going to set up in Assam? Is there any opportunity for entrepreneurs here?
Thank you for the question. The opportunity is very big, because for us, we cannot keep bringing everything from the rest of the world and just snap it together. We have to build local ecosystem. If you look at very sound semiconductor countries like Taiwan as an example, all the ecosystem is what makes the semiconductor industry compete and thrive. So from that standpoint, building the ecosystem implies that, for example, if some people on the software, on the design side, they play a very critical role. So we look forward to more and more local entrepreneurs build the ecosystem on semiconductors working along with us.
So my next question is for like, if you want to collaborate with Tata, like what would be the channel, like how could we approach?
I know we have a lot of panel people, and so I hesitate to be the only person answering because there is a. Okay.
Hello.
So the easiest way to work with us is to bring a business proposal, right? So, like to be honest, there are many people that approach me and say, "You tell me what I should do," right? If I tell you what I should do, I would have done it myself. So I would like people to think about this is the industry, these are the challenges. What are my skill sets and how can I contribute and bring a business proposal? We can iterate from there. So my suggestion would be that I want bold drive coming from the entrepreneurs to drive it. Otherwise, we bias you with our thoughts, which is not a good thing.
So basically, like, is there any contact person or any like whom I can approach for, you know, kind of approaching for with a business proposal, something like that?
Very much your question actually. But general question on behalf of you, I can ask to Dr. Sharan. Dr. Sharan, many people are from small institutes or state universities. So, what industry wants nowadays? We want fruit without trees actually. Right? So, without science, we want output. Basic science is not strong, nothing will come out. So, how Tata Semiconductors is going to fulfill the social responsibility for the state of Assam so that the small colleges, small universities are also benefited due to your very high level industry and under your leadership. Thank you.
Hello. My question with MD sir, Manamdra is, sir has told us that.
Thank you for the question. First, we are Tatas, and by definition, Tata implies social responsibility is built into your DNA. And so we are very conscious. We have not made any public comments on our thought process, but as and when our plans will come in, and we will engage across multiple fronts, because our vision is to see how we can uplift, because we exist, the society plays a very key stakeholder. Not that they are not there for us, we are there for them. So we will engage on multiple fronts. Just to give you a few examples, engaging on uplifting the educational levels. Like you said, fruit without trees, right? But our approach is build the trees. Maybe we get fruits, maybe somebody else may get fruits, but our DNA is to build the trees. So that is our motivation behind foundationally going to not just these academic institutions like this, which is short-term plan, but to go to schools and build it up from the schools, right? And also our industry is in such a way that we can engage people and engineer as well as we can engage a science graduate. So you will see us hiring not just engineering disciplines, but physics, chemistry, and even biology and other related disciplines, mineralogy and other disciplines. So that is how we will contribute, just to give you an example. Thank you.
Sir, last question I have.
Yes, only one question, please.
I'm a research scholar in IIT Guwahati. So basically we work in the field of IC design, RFIC design. So we had a tape out of around 4 tape outs from our lab. So we give it to TSMC through Muse or Europractice. So my question is that, so whatever the basic problem that we face is fund. So my question is, we have experienced people in this domain. In India, you can count in fingers who did RF tape out at 39 giga, and we are doing now 270 giga tape out. So my question is that, if you have any plan to collaborate with institute, so that you can provide fund to us, and we'll give tape out to you.
Thank you for asking the question. The way industry, semiconductor industry typically supports university is by having a shuttle concept. Have you heard of it? Okay. So Tata will also have a shuttle because the mask is so expensive. that whether you make 1 unit or 10 million units, the cost of the mask is the same one, which is very astronomical number. So the way we can democratize semiconductor process for everybody, for academic institutions, when they want like 100 units, is that we have a concept called Shuttle. So within the same reticle on the mask, we will have seats, what is called seat. So let's say within the reticle we have 100 seats. We will give each seat to academic institutions and other people. So there is a sharing of the cost. So if you pay for the full reticle by yourself, it's significant amount. But you only pay for a seat, which is very economical, and Tata Foundry would do something similar, so that we are facilitating people who are not on the mass scale, particular academic institutions.
So like TSMC has a university shuttle program for in US. So do you have any similar kind of program so that we'll give our...
Our foundry is just taking ground, and when the foundry is built, and Sir asked about social responsibility, this is all part of social responsibility, helping. So we will ensure that somebody's idea doesn't get killed for lack of funds. So having a shuttle is one way by which we can do it. Thank you.
Thank you very much. I now request all the participants to be seated for some more time. We'll have some interaction with our media personnel. They also would like to talk to our guests. I request Soumya Madam and Dr. Lakshmanan to please come on the stage. The media wants to take a small bite from you all about your views on the Ministry of Education as well as the Government of Assam on how this industry is going to play a major role in this region. I request all the media persons to please come in the front. No, here. You can come on the stage. So they'll. Thank you, madam. Thank you, Dr. Lakshmanan. I request the panelists to be seated. It's okay. Maybe the questions are there for you also. Yeah, sure. Yeah, please go ahead. Yes, please go ahead. You want to start with Dr. Lakshmanan? Okay, you can start with Dr. Charan. Fine. I request Dr. Charan to please step near this poster. They want to do a one-to-one with you. So what we'll do is, I think you should speak in the mic, the audience has to think. Very sorry, I think, we'll have the media interaction separately. They would like to talk in a closed, this room. So before we end, I request the organizers to please felicitate our guests who just joined in this panel, Professor Katiyar and Professor Nemade. May I request you to please come forward to felicitate our panelists. A big round of applause to the panelists, please. Thank you for spending your valuable time and being with us today morning. It's okay. You would have come. Go. Okay. Thank you, Professor Katiyar. Let us move ahead with the program of one more MOU signing.
We would like to call Mr. Vijay Kumar, Executive Vice President of Starburst, onto the stage. We also like to call Sri Kumar, Vice President, Government Relations, onto the stage. I request Mr. Vijay Kumar, Sir, Executive Vice President of Starburst, to say a few words.
Good afternoon, everyone. I will not be very long as it's lunchtime. Just 1 minute, please give me. And I would like to thank our IIT director, Ms. Ahuja, who took such effort to bring us from France to India. And our CEO couldn't make it, but I'm representing Starburst. We are the #1 global aerospace accelerator. And we have already invested 1.9 billion in 200 startups across the world. The reason we have selected Assam, 4 months back, I came here to visit your IITM park, and I discussed with a couple of you young entrepreneurs and others, and we found that Assam has the spirit and IITM has the spirit to do something new. And the welcome and the knowledge, and some of you have been in touch with me, and Satyam, Atharva, and others put a lot of effort, and today we are a big moment. We are signing the MOU. This is going to have a 100 million euro VC fund along with that. And just to give you a small brief about Starburst, Starburst was founded 12 years back, but today they are working with the NATO, they are working with the NASA, they are working with Israel, we have our office in Korea, and we are the leader in aerospace, space and defense, also in deep tech, quantum, and a few other area. And in India we are rolling out, and we recently signed with IIT Madras and also with RRU Raksha University, and we are putting a major program with the AICT for 10,000 engineering college. And today I would like to be grateful to IIT Director Mr. Ahuja ji, who took the time to make it happen. And so just to give you a small one slide only, after that I leave. It is so you can see, I don't know if you are able to see. We are working with MIT, we are working with the French Blast, we are working with Israel, we are the NATO accelerator. All of you, please take your time, type Starburst, and you will see all the video will come, how a acceleration is done. This is the first time in India we are getting such accelerator. You have so many incubators in India, but accelerator to come along with the IIT, train you, bring the international IP, also the technology, and see whether this technology that you are creating in India is already available across the world. And today we have more than 20,000 startup who is already connected to us, and in that 2,000 we are actively pursuing. And now we are creating with the IIT Rupar and IIT Guwahati a program that will benefit all the student, all the faculty. Thanks to this, so many corporate will come and open their research center in India. That's
Now I request Mr. Vijay Kumar, Sir, Executive Vice President of Starburst, Sri Kumar, Sir, Vice President, Government Relations, and Dr. Lakshmanan S. Sir, Secretary to Government of Assam, to join on stage to sign MOU between IIT Guwahati and Starburst. Now I request to sign MOU between IIT Rupert and Starburst. Now I request everyone on the stage to be present for the group picture.
Now I want to invite Professor Shubhendu Shekhar Bagh, Associate Dean R&D, IIT Guwahati, for a vote of thanks.
Good afternoon to all. It is very late and time for lunch, so I am making shortcut for this vote of thanks. Though the thanks to the guests and the people who are coming here, the respected guests, the thanks is big. We are grateful to all the dignitaries on the dais, presently the panelist members, as well as the dignitaries on the dais during the inauguration of this program. So particularly Dr. Charan Gurumurthy ji, Lakshmanan ji, Madam Soumya Gupta, Joint Secretary, Ministry of Education, Sri Narayan Kanwar ji, IAS Secretary to Government of Assam, our beloved Director, Sir, my dear colleagues and students, participants, we are very much thankful for making this program a grand success, and we are hoping with the help of Tata Semiconductor Private Limited and with the support from our Ministry, Education Ministry, Ministry of Assam government, we are forcing and expecting and very much eager to establish a center of excellence in semiconductor domain at IIT Guwahati. We will be the opportunist for having this one with the help of them. If their kindness grants us, then we will be having a semiconductor training center also. So we are very much thankful to the students who dedicatedly make this event a grand success, particularly few of our colleagues who dedicated this program and very much given the effort to make it grand success. Thanks to IIT Guwahati supporting staffs and the vice chancellors of different universities who have come forward here to participate in this thought-provoking discussion. I am surprised and overwhelmed by the thought-provoking, most interactive teaching learning process by Dr. Charan, and this will remain in my heart lifelong. Thanks to all the audience who make this program is a grand success. We are hopeful that the IIT Guwahati could take the lead to support whatever the Prime Minister's vision for Atmanirbhar Bharat by making the Center of Excellence in Semiconductor and helping and supporting the Morigaon Center for the Semiconductor, which has been established in a broader sense to lead to the India in indigenous technology development for semiconductor. Thank you all, wish you all the best in your future. Thank you, Jai Hind.
As we come to the end of this session, we'll now have a tea break. We also have an exhibition showcase during the tea break. Participants are required to visit the exhibition for interaction feedback or any suggestion. Please join us here for the next session.
Just a motivation. We have come to meet you. Pleasure to meet you. I truly appreciate and we need your help.